maximum number of electrons. Maximum number of electrons in a subshell. Maximum number of electrons in a subshell of an atom. Subshell of an atom is dash. Question reads in this fashion. Maximum number of electrons in a subshell of an atom is. There are 4 choices given. First choice A is 4l plus 2. Second choice 2n squared. Third choice 4l minus 2. And fourth choice 2l plus 1. Here I have mentioned only the choices. Actually, the choices will be written as A, B, C and D. Only one choice is correct. Here n is the principal quantum number we have seen. So n can take values natural numbers 1, 2, 3 like that. Next L is the value. So n is the independent variable. Then L is the azimuthal quantum number. L takes the values 0 to n minus 1. 0 to n minus 1. Here L represents subshell. L represents subshell. We have to identify. So already we have seen azimuthal quantum number is a measure of subshell in which it is present. 0. What is meant by the 0 to n minus 1? Let us fix n equal to 2. N equal to 2 means L value 0, 1. L value 0, 1. Then third one is degeneracy, magnetic quantum number. It takes the values minus L to plus L. Minus L to plus L means that minus L minus of L minus 1 like the, it is like an integer 1 to L. So this is natural numbers. This is whole numbers. 0 starts from 0. Whole numbers. This one integers. Integers means Z. So total number of values will be 2L plus 1. Let us give an example. If you put L equal to 1, M equal to minus 1, 0, plus 1. There are 3 values. There are 3 values. So it is nothing but 2 into 1 plus 1. 2L plus 1. So M equal to 2N plus 1. There are 3 subshells for p orbital we have studied. So in each subshell lastly 2 electrons. So if you have to multiply here 2 into 2L plus 1 gives 4L plus 2. So in a subshell, so total number of electrons in a subshell is 4. Total number of electrons in a shell is 2n squared. So total number of electrons in a shell is 2n squared. In a subshell is 2n plus 2. So for this question, choice A is correct. If the question is asked in this fashion, total number of electrons in a shell, if it is asked, in that case it will be 2n squared. That is to be noted. So for the current sum, the choice is A. So this finishes the thing, how to arrive at the choice. Here you got, so all the versions are given. L and M, N, S have to be noted. So this 2 is because of spin quantum number. One with the clockwise spin, another with the anti-clockwise spin, which we have studied. So this is the application of what we have studied in terms of quantum numbers. Next one is electronic configuration. So electronic configuration, there are 2 types: ground state configuration, excited state configuration. Excited state means due to higher energy content, they will move to the other shells of same energy. Other shells of same energy. That will be, so if a system will be stable, if it is having half-filled, we might have studied about half-filled configuration and completely filled configuration. In the electronic configuration, there are 2 terms. One is called half-filled configuration, another one is called complete. For example, S orbital capacity is 2 electrons. If 2 electrons are there, it is called completely filled. If it contains only 1 electron, it is called half-filled. So take the case of p orbital, 3 types of p orbital, 3 into 2, 6. So 6 electrons are there in p orbital, completely filled. 3 electrons means half-filled. If the system contains half-filled or completely filled, that will be stable, most stable. So the system will rearrange itself to have a more stable. Any process is directed towards the stability. Only system will be stable only if it is having desired configuration. So here they have given the question as, which of the following does not represent ground state electronic configuration of an atom? There are 4 choices are given. So all the choices, let me read. Only the outermost choice we are bothered about. So all the choices 1s2, 2s2, 2p6, 3s2, 3p6, up to this it is same for all the 4 choices. So up to third shell p orbital it is filled. Then next to 3s we have 3d, then 4s, then 4p. So 3s, 3p, 3d, this is the arrangement. But 3s, next to 3s is 3p. Then comes 4s, then comes 3d, then only comes 4p. This is based on the off-Gauss principle. This is to be noted for off-Gauss principle. So the 4 choices vary only in the valence configuration. Valence configuration means outermost configuration. 1, 2 are inner configuration. 3 and 4 are outer configuration. First choice 3d8 and 4s2 it is reading. Second choice 3d9 4s2 and third choice it reads as 3d10 4s1 it reads. Fourth choice 3d5 and 4s1 it is mentioned in this fashion. So 4 into which up to 3p6 here if you see the periodic table, helium, neon, argon. So argon configuration is up to, so argon configuration is same in all the configuration. It is represented as capital AR, small r. So capital A, small r, argon configuration, electronic configuration is repeated and last configurations are differing, which is not possible. The question asked is, which of the following does not represent? 8 plus 2, it is okay. So 3d8 for second one, 3d9 4s2, 3d10 4s1, 3d5 4s1. Here d10, d capacity 5 types of d orbital are there. Each orbital will contain 2 electrons. 5 into 2, 10 electrons are completely filled. This one half filled, completely filled, half filled. So the second 4s2, the second electron will come inside to get 3d10. It will not be like this. If at all the configuration is 3d9 and 3d8, 4s2 is okay. And 8 plus 10, 10 up to 10 electrons filling order is correct. What happens to the 11th electron? That is to be noted. 11th electron will be 10 plus 1. So 9 plus 2 also 11. 10 plus 1 also 11. So where does the 11th electron goes? Here totally only 10 electrons. They follow only the off-Gauss principle. Totally 8 plus 2, 10 electrons. So 5 plus 1, 6 electrons. No question for the first and last choices. First and last choices, number of electrons are different. But second and third choices, total number of electrons is 11. So up to 10 electrons, what happens to the 11th electron? 11th electron goes to the 4s orbital or 11th electron goes to the inner 3d orbital. Question arises. So 3d10 is half filled, most stable configuration. In order to attain most stable configuration, 11th electron goes to the inner orbital 3d10. It will not be in the 3d9. So it is not the correct configuration. So choice B is not the correct configuration about this. So choice B is the answer. So question reads, which of the following does not represent? So second choice does not represent the configuration because of the stability reasons. That is to be noted. So this finishes the tackling up of this question. Next question, reads as, it is a direct question somewhat based on what we have studied. So this question let me read, then we will see. It is based on only the concept of quantum numbers. We have studied about the 4 types of quantum numbers. The question reads as, 2 electrons occupying same orbital are distinguished by dash quantum number. Let me read the question once again. 2 electrons occupying the same orbital are distinguished by dash quantum number. In the dash, they have given 4 choices: principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. Already in the theory, we have seen that as per the Pauli's exclusion principle, no 2 electrons can have all the quantum numbers same. Same orbitals means if 2 electrons are in the same orbital, their principal quantum number will be same, their azimuthal quantum number will be same, their magnetic quantum number will be same because they are in the same. But their spin quantum number will not be same because one spins in the clockwise direction, another spins in the anti-clockwise direction. So here the correct choice is spin quantum number. So let me read. So 2 electrons occupying same orbital are distinguished by spin quantum number, not the other types. That is, this finishes the thing. Next question. How many electrons can fit in the orbital for which? How many electrons? How many electrons can fit? How many electrons can fit in an orbital with n value in an orbital? Fit in an orbital with n value equal to 3 and L value equal to 1. The question asks this: how many electrons can be fit into the orbital with n value equal to 3 and L value equal to 1. So there are 4 choices given: 2, 6, 10, 40. 4 choices are given. So the question asked is, how many electrons can fit in an orbital with n value equal to 3 and L value equal to 1. So in any orbital maximum we have studied 2, immediately we will be tempted to write 2 electrons. Just now previous question we have seen 2 electrons. In any orbital 2 electrons. But there are orbitals with a degeneracy. First n equal to 3 means K, L, M shell. And L equal to 1, 0, 1, 2. This is S orbital, this is P orbital. So the electrons are in the M shell and P orbital. Electrons are in the M shell and P orbital. But we have studied that there are 3 types of P orbital: Px, Py and Pz. Each orbital can accommodate 2 electrons. Total number of electrons accommodated is 6, which gives the correct answer. It also, whenever we work a sum, if you work in a erratic manner, we will end up with the answer. That answer will also be coming into picture. So we have to be careful about tackling this problem. So for this question, choice B, number of electrons. So 6 electrons are there in the given. Now next question, last question, reads that which of the following pairs of d orbitals, which of the following pairs of d orbitals, so there are pairs of d orbitals, will have electron density. This is actually the previous question as well as this question. These previous 3 questions, 2 electrons occupying in same orbital are distinguished by spin quantum number, number of electrons that can be fit into the orbital with the n equal to 3 and L equal to 1. These are the previous last year questions, phase 1 NEET exam questions, phase 1 and phase 2. This also NEET exam question, phase 2. So it reads that which of the following d orbitals, will have electron density along the axis. 5 types of d orbitals. They are represented as xy, yz, xz, z squared and x squared minus y squared. You got to put the d in all the cases. We have seen that there are 5 types of d orbitals: dxy, dyz, and dxz, dz squared, and dx squared minus y squared. Xy means in this pattern. You got to be careful about the noting. This is x-axis, this is y-axis. D orbital is having 4 lobes. D orbital is having 4 lobes. The 4 lobes are situated along the xy plane. XY plane means, but the lobes are not along the axis. They are diagonally with respect to the axis. They are not along the axis. The question is, how many d orbitals are along axis? That is the question. There are 2 d orbitals along. Out of 5 d orbitals, only 2 of them are along the axis. Which are they? Questions are asked. So you got to be, so different choices are given. One of the choices is these 2. dxy, it is not along the axis. So if you write y and z, it will also be in the diagonal fashion. You got to remember xz. So for understanding purpose, I have left the third axis. Not that third axis does not exist. xy means xz is existing. Yz means x is existing. That is, our aim is how it is distributed. But here dz squared is distributed along x-axis and z-axis. 2 lobes are along z-axis and 2 lobes are condensed as a ring, like a Saturn ring, along the x-axis. So dz squared, the lobes are along only the z-axis and x-axis. Last one, dx squared minus y squared. Here also this is along the axis. So these 4 will look alike. All the 4 lobes will look alike, but how they are distributed, they have to, if they are diagonally distributed, it is represented xy, product, x and y, y and z. If they are distributed along the axis, it should be represented as x squared minus y squared. So these 2 are the orbitals which are positioned along the axis. Out of the 5 orbitals, so first choice reads as dz squared and xz. dz squared is correct, xz is not correct. Second choice reads as dxz and yz. They are not correct. They are not along the axis. Third choice reads as this one, correct choice, dz squared and x squared minus y squared. Fourth choice, xy and x squared minus y squared along the axis. Xy is not along the axis. In this way you have to be noted. So this finishes the tackling. So in the positioning of d orbital, you have to remember that lobes are positioned along the axis only for 2 versions. Other 3 versions, they are distributed between the axis, diagonally opposite to the axis. That is to be noted.